Hi, this is for number 4. Number 4 has many different parts. A equals ELC. E is the molar absorptivity, and that's the number that describes how strongly your solution absorbs light of a certain wavelength. It's different for every wavelength, and it's different for every solution. Uh, L is the length of the light's path, though. So in this case here, L is 1 centimeter because the light only goes through 1 centimeter of solution. You see that? C is the concentration down there. So um, the first part of 4 is just to write a guess. What do you think? Do you think that the wavelength will affect the absorbance versus concentration relationship? We saw in number 3 that the relationship is linear. When you change the concentration, the absorbance changes in such a way that those data points follow a straight line. So do you think that's going to be different if you use a different wavelength? It's just your guess. There isn't. The only wrong answer would be an answer that you don't put, or an answer that doesn't answer the question. So either whatever you think, it's really a guess. So this is the other part of number 4. You have to get some data, and this data is in a table form. So since we were using Google Sheets before for number 3, we can just use Google Sheets again. That's okay to do. You could do this on the same sheet, or you can do this on a new sheet. I'll just do it on a new sheet so I don't confuse anybody watching this while taking care of kids or something, So, so I have a solution color, beam color, value, absorbance. So let me just highlight this whole table there. I'll just highlight that and then copy it. It's best to copy with Control-C rather than to right-click. And then I'll just go to my new sheet, and then type Control-V. If you're using a Mac, of course, it's Open Apple C and Open Apple V. And here is the table, nicely pasted into Google Sheets. But I don't need this other stuff, extra stuff that I copied by accident, so I'll just highlight that and delete that. Now, I'm going to take some data here. Let's see how much data I need to take. Looks like I need 2 rows of data. Okay, so I'll just say that I'll just pick a solution. I'll just pick cobalt 2 nitrate. Ooh, the beam color is green. All right, so then I type in there, beam color is green. And what's the value in nanometers? Well, I'll show you where that is. There it is, 549 nanometers. All right, you see what I'm doing? 549 nanometers. And what's the absorbance? Oh, the absorbance, it's 0.47. Okay, the absorbance is 0.47. And now to the same solution, I'm going to set a different wavelength. It's going to be the same color as the solution. All right. So the solution is pink. So now I'm going to click on variable here, and I'm going to move the rainbow slider until that light beam is the same color as the solution, pink. So I'm not getting pink at all here. So I'm just going to have to get as close to pink as I can. That's like orange. It's like magenta. I think that's as close to pink as I'm going to get it. So now what do they want? Back to my sheet. The beam color is it's magenta, right? And then the value was 646 nanometers there. 46 nanometers. Oh, you don't have to put units because the units are already written there in nanometers. I can just erase this. Okay, that's good. And what's the absorbance? The absorbance was 0.03. 0.03. Okay, so wow. Already we could see something. Absorbance was 0.47. Now it's 0.03. So if I have the beam color that is the same color as the solution, something like pink, the absorbance is almost 0, where it wasn't almost 0 before. So the absorbance drops a lot. So let's try this with another solution. Of course, I hope you will use different solutions than me, and I hope I'm not using the same solutions that someone else is already using. So here we are with, what is this? Purple? Try that. So beam color is purple. It might be brown, I'm not sure. And then what's the value there? The nanometer 780. You see that? 780. 180 nanometers. What's the absorbance? That's 0.96. All right, 0.96. The beam color. Oh yeah, and I'm going to change the beam color. Oh wait. Oh yes. While I was doing the fixed wavelength, I should have typed preset. Lucky for me, the default was the preset. All right. So now I'm going to change this. I'm going to change it so that I match the color of the solution. Ooh, that's a pretty good match. No. Yeah, I think that's a pretty good match, right? I'll call it light blue, and then it's 483 nanometers, and I get 0.01 absorbance. Wow. So light blue, it's 483 nanometers and 0.01 absorbance. It was 483 nanometers, right? Yeah. Okay. So that's great. Now look, that's almost zero. So the closer you get the beam color to the solution, apparently, the less absorbance there is. That's very interesting, is it not? So how are they related? What combinations give most absorbance? So I'll let you answer that question. Let me just make it a little clearer. This is like the most absorbent. This is the most absorbance here on this whole graph. This is more absorbance than that. This is more absorbance than that. That's what they mean by the most absorbance. So here we are. Okay, now choose a solution and set concentration path length. Okay, so now they want you to get absorbance of different wavelengths. So they want you to get the data, and then they want you to, oh, they don't want you to graph it. They just want you to get it. Okay, well, that's fine. So I'll just copy this here. They want you to do different wavelengths this time. Okay, so I'll just put Control V there. Didn't quite copy the way I wanted it to, but that's okay. I'll just move the absorbance next to the path length. So that's path length. Okay. Oh, I'm sorry. That's not path length. That's that was wavelength. Wavelength. Silly me. Okay. So I'll pick a solution, any solution. My favorite color is green. Oh, but I already did that, so I'll use yellow. So I'll just pick a wavelength 437 nanometers, and I get 0.24 absorbance. So 437 nanometers, 0.24 absorbance. I'm going to do this for 8. I'm going to do this for 8 data points. It's a little bit boring. 473.05. 473.05. You just keep on doing this for 8 data points. 623.01. 623.01. Keep on doing it. Not sure why they're having you do this. 537.01. I'm actually a little annoyed that they're having you do this. 723.01. 3.01. Because this has 380.17. 380. No discernible educational value to me. Do I have 8 points? 1, 2, 3, 4, 5, 6. I mean, I think the concept here is that different wavelengths give different absorbances when all the other parameters are the same, like it's the same solution, it's the same concentration, the path length is the same. If you change the wavelength, you change the absorbance, and the farther away you get from the preset wavelength, the worse the absorbance gets, and the closer you get to the color of the solution, well, you see something different happening to the absorbance, and I won't tell you because you will figure that out by your own observation.